Welcome back, engineers. We are discussing common techniques and algorithms in system design, and in this video let's look at a demo for Bloom filters. I hope you're ready. Let's get started. So before we go into the demo, let's have a quick recap about what were Bloom filters and why were they useful, right? So Bloom filters are a bit array which are used for doing membership checks. So if you want to search for something in a long list of strings, just to check if that string exists or not, we can make use of Bloom filters to make it more efficient, right? For example, if you have items like cat and dog and bat and eat, you can put all of them in a bit array and you can check if some item exists on this array or not, right? So if I'm putting cat in this, some bits are activated. When I'm putting dog, some other bits may be activated. So how does this work? So when I want to put some element like cat into the bit array, I pass it through a bit list of hash functions, and each hash functions return some value that is appropriate for this, the size of the bit array, and then we activate that particular element, right? So for example, when I'm passing cat through these two hash functions, each of the hash functions returns some index for which I can activate the bit if it is not already activated, right? Similarly, when I pass dog to the hash functions, it gives out a different set of indexes and I will activate those two. And then when I want to actually search for something, let's say I'm searching for bat, I'll pass bat through the same set of hash functions and it will give me different types of indexes like 0 and 1 in this case. And we can see that 0 and 1 are not activated in the bit array, so we can give a firm no, right? So the Bloom filter can actually say when something is definitely not present in the list, but when it is present, it is a just maybe yes. Why? Because it can lead to false positives as well. For example, we saw an example of eat, right? So when we were passing eat into the same hash functions, it was giving out indexes 4, 3, and we can see that 4, 3 are already activated in this bit array, but these elements were not added from the word eat. They were added by cat and dog, right? They were specifically added by the word dog here, right? So even though the bits for eat are showing up as ones in the bit array, it is just a maybe yes, right? So this is when we go to the actual database or some data layer to actually check if something is present. But the benefit that we are getting from Bloom filter is we can definitely get a firm no, right? This is especially useful in many situations like web crawlers, CDNs, browser caching, databases, spam filtering, spell checkers, and more, right? So there are many use cases for this Bloom filter, and now let's have a quick demo about how all this works, right? So let's go to the UI. I took 4 different hash functions: MD5, murmur3, xxHash, and fnv1a. I'll leave the links to the description below. You can check out these hash functions. So what we are doing is whenever we want to enter an item into our bit array, so in this case the size of our bit array is 100, but generally it will be quite larger than this, maybe in the 2 to the power of 32 range. So what's happening here is when we are passing a word called apple, it goes into 4 different hash functions, and each of the hash functions will return one index number which will be somewhere in the range of 0 to 99, and then those bits will be activated. So if you see here, for the word apple, we got 4 different hashes: 31, 20, 33, and 23. So these 4 bits are activated. Now let's say I'm adding something called Samsung, let's say. There will be some other bits that got activated. So there is 98, 73, 79, and 31. So 31 is a common bit among these two items, but the other bits are activated now. Okay, so let's add some more. Let's say we are adding Sony. Maybe we can also add OnePlus, right? In this way, we can keep on adding stuff to our bit array to activate different bits. So how do we use this now? Let's say I want to search for Nokia. We know that Nokia is not present here. So if we do a check, we get the statement that Nokia is definitely not in the set, right? So for this word Nokia, these were the hashes generated: 8, 45, 74, 61. We can verify. 8 is nowhere present in the history list, 45 is present, 74 is not present, 61 is not present as well, right? So in this case, we can definitely say that Nokia is not present in the list. Now, in order to check the case of false positives, I have created a script for generating some strings for checking false positive case. So you can find the script here. You can easily run the script. Just say Python 3 find false positives, and it will give us a string, and this will give us a bunch of items to add to our Bloom filter, and with some potential false values, right? So let me quickly add all these items to the Bloom filter array, and then I will see you to check false positives, right? Let me add all this. Okay, I have added all these items to our Bloom filter. You can see them here in the history list. So the reason I did this is our Bloom filter array size is quite large, 100, right? So it's not reasonable to find English words to actually make a case for checking false positives. So it's a script that generates random English characters, and we can make use of this to actually check for false positives, right? So what do we know now? We know that all these bits are now activated from all these different words, let's say. And let's say I want to search for something that is not part of the previously added items. Now let's say I want to search for something KBBTT that is not part of the previously added items, but it's possible that these bits are already activated. So if I pass through this and do a check, we can see that 44, 0, 64, 88 are the hashes given by these 4 hashes for this term, and we got the result that KBBTT might be in the set. So it's a possible false positive, right? Why? Let's have a look. So 44 got activated by this word, 0 got activated by this word, 64 got activated by this word, 88 got activated by this word. But this word was never added to our list, right? But since the bits are already activated, we are getting a might be in the set, right? So at this point, we can go into our database or whatever to check whether this actually exists or not, right? But what we can definitely be sure is if something is not present in this long list of strings, we can be sure that it is definitely not present, right? That is the advantage of Bloom filter. Now let's look at the code. The code is actually quite simple. We go to the Bloom implementation. So we have an initializer. We are deciding the size of the array. The larger the size, the less chances of false positive. And then we have the number of hash functions. In this case, I am using 4 hash functions, which is MD5, murmur, hash3, xxHash, and FNB hash, right? So basically all 4 of them use different algorithms to generate a hash, and we are just doing a modulo of self.size, which is the size of the bit array, so that we get some index number in the range of 0 to 99 or whatever may be the size of the bit array, right? And then when we are adding, what are we doing? So we are taking an item as input and we are passing it to the hashes function, which will have 4 different hashes returned to us, and then we are going to go through the hashes and we are just going to activate them in the bit array, right? That's what we are doing here. And when we are checking, we do the same thing. We take an item as input, we pass them to the hashes function, we get 4 different possible digits, and we check the possibility. If all the bits are activated, then we say possibility exists, otherwise we say it's definitely not possible, right? That's all we are doing here. And the rest of them is a simple Python server for exposing the APIs, and the README is supported for you to play around with this, right? So the code is already available on GitHub, guys. Definitely check it out. If you have any questions, definitely let me know. Thank you so much for watching. Please leave a like if you found this helpful. Please subscribe if you haven't done already. I will see you in the next one. Cheers.